All right, we're here in lesson 3-9, Precalculus. Rochelle, you are gone, so you're watching the video. So hello, Rochelle. You want to say hi, Daisy?
Hey, Rochelle.
So today is December 10th. Today is a lot of review, and then so is tomorrow. Tomorrow's just review on top of review, just adding one new step a day. So, all right, magnitude of AB. How do I find the magnitude, Daisy?
Length.
It's the length, yeah. What is the formula? Do you remember? Pythagorean theorem?
Oh, a squared plus b squared.
Yep. A squared plus b squared was equal to c squared. And to get c by itself, what do we have to do to a squared plus b squared? Yeah, that thing, which is the square root. Perfect. That is the formula that you need to know. Yeah, and then you're good for magnitude. Direction of AB. Do you remember how to do this? This was where we had the tangent. So to remember this guy, this was where we had the triangle. We had this theta, and we knew we were trying to look for, or we had A and B. So this was A, this was B. We know that there's one trig function that relates A and B with theta. Was it sine, cosine, tangent? This is opposite over adjacent, so TOA.
Oh.
So TOA, so tangent, it's tangent. Sine and cosine both need a hypotenuse, but tangent only needs the opposite and adjacent. So if it's tangent, that means tangent of theta is equal to b over a. You take the arc tangent of that, or the inverse tangent of that, to get theta. So that means this is equal to inverse tan, or arc tan, of b over a. B over a. So there's the second formula that you need to know, and this was the one that you did for the weekend 3-8. Components, the x component and then the y component. Do you remember what were you just doing for the warm-up, right? Here is the warm-up. How did you find this x coordinate? What was the thing that you punched into your calculator?
It was like cosine. Oh wait, it wasn't like theta equals something.
No, just go for it. Yeah, cosine of what? Cosine of the theta, because if you have, so cosine of theta, and then what did you multiply that by? The magnitude, yeah, just that guy, the magnitude. So there's u, and then you put double bar, u times cosine, and then how did you find the y direction?
Magnitude times sine of theta.
Magnitude is right there, times sine of theta. Perfect. Yeah, that's all the review that we need to know. We know how to find the x component, the y component. So let's talk about adding vectors. So let's say I have these two vectors, w, v, and w. V is 50 degrees and has a magnitude of 5. Our argument, or our theta, is 160 degrees for vector w, and it has a magnitude of 8 and a length of 8. How do we add those two together? What are your thoughts?
Well,
can you just add 50 and 160 to get 210, add 5 and 8 to get 13? So 13 at 210 looks like that. So when I add those two together, does that look right? Remember, it has to be tail to tip. Tail to tip means it should be coming right there. So we're looking for a point roughly in that vicinity, but when I add the argument, or I add that angle, that theta, then I get something down there. So that's a problem. So you can't just add them like that. But we do know from yesterday, well, not from yesterday, but from Friday, that we can turn 160 degrees with a magnitude of 8. We can turn that into x and y components. If I find the x and y components, I just add the x's with the x's, y's with the y's, and then that's the same thing that we were doing before. So that's the answer. We can only add these vectors if we first convert them to, what's that form? What's that form where you have just the x's and the y's? This was with the argument, or the theta and the magnitude. So there's theta and magnitude, or angle and magnitude. What's that other form called?
oh,
Yeah, convert it to component form.
wait, what does that even mean though?
Good question. What does that mean? Component form just means you have an x and a y.
Oh.
So I can put that underneath there. Convert it first to x comma y instead of your length and your direction, instead of your magnitude and your theta. Instead of doing that, do x comma y. Get them both converted, and then you're done. You just add them. There's an explicit formula because I know that you girls told me that you really like formulas, so here is your formula. So if I'm adding vector v and vector w, I need to get the x component of the v and add it with the x component of the w. And that's the formula that we've seen before when I just gave you the two component forms. Now I'm not giving you the component form. I'm just giving you a graph that looks like this. And I say, okay, now convert them to component form because you know how to do that, and then add them. So converting them, I'm using this same formula right here. And I'm basically saying take the magnitude of v, so v magnitude times cosine of theta. That's the x component. I need to add that with the x component of vector w. So what am I going to write here, Daisy? So I just wrote, this is the x component of v. I just wrote this term. I need to write the x component of w. I need to write this second term now.
Vector w? Or
what is that called?
Magnitude.
Magnitude of vector w times cosine of that theta. And I guess these thetas are not the same theta, so is there a way to denote them? We'll say theta v and theta w, just so that they are different thetas. These are not the same theta. All right, and then Daisy, you want to do one of these and I can do the other one for the y components? How do I get the y component of vector v?
So it's the magnitude of v times sine of theta.
There it is, yeah, times sine of theta, and we'll say theta sub v, so we know that's the theta for v.
Does that actually matter though?
It does. It matters for the formula. In case you just wanted to show someone the formula, they'd be like, "These are all the same theta," and then you'd be like, "Oh, they're different," and that's just the way to say that. So it doesn't matter really because you know that they are different. And then I add that with the magnitude of w with vector w times still sine because both of these have to be the y component of that theta vector w from vector w. So there is your full-on formula. It looks really gross. I just like this would be the nicer rule, like just convert them to component form and add them because you know how to do that. But there is the formula. And then after every single time that you do the formula or use your math to add the vectors, you need to check your intuition. So our intuition, for example, said that when we did tail to tip, we should end right about there, somewhere right there. So just check that it's roughly where you think it is. After adding the vectors, checked that the answer isn't, I was supposed to write is in, but I wrote in, is in the correct spot. And at the bare minimum, correct quadrant. It should definitely be in the correct quadrant, if not more or less the correct spot. Because you can roughly generalize and be like, oh, okay, I can put those two tail to tip in my head and be like somewhere around there. So I should be looking roughly about, I don't know, negative 7, negative 6-ish for the x component. All right, so let's try an example. And it's the same problem that I just showed you up above. So let's find that answer in component form. So Daisy, tell me what to do.
I'm still a little bit confused with the formula.
Okay, let's just do example 1 together. You don't need the formula, it's just there as a backup.
Okay.
Let's do example 1 together and I'll let you do example 2 and Rochelle will let you do example 2 by yourself. All right, so on this one, I need to convert v to component form. So pretend that w doesn't exist. Just do v, 50 degrees and 5. How do I convert that to component form?
So it'd be theta equals 5 times the cosine of 50 degrees.
Yeah, so we have 5 times the cosine of 50. I cannot write my 5s very well. 50 degrees. That's the x component, and the y component is
5 times sine of 50.
all right, let's figure out what that is. All right, so I have 50 degrees. I am in degrees because it says I can choose to convert to radians. I take cosine of that, I multiply it by 5, and I get 3.21. roughly. I've approximated now. And then 50, I take the sine of that, and I multiply by 5, and I get 3.83. All right, Daisy, is that the answer that you're also getting?
Yeah.
Perfect. Or are you just following along?
No, I don't.
Oh, nice. Okay. And let's do vector W. I'll do it up on the board, and then you can check to see if you got the same thing. Vector W, convert that to component form. So we know that it's going to be 8 cosine of 160, comma 8 sine of 160. All right, get out of calculators. 160, taking cosine, we're going to multiply that by 8. And that makes sense because we have a negative x value, so we have a negative 7.51? No, 5.2, I rounded incorrectly. 5.2. And then I have 160, I need to take sine of that, and then multiply it by 8, get to 2.74. 2.74. All right, I'll wait here, Daisy, and make sure that you get the same answers. Yeah, you got it? And then I just need to add the x's and the y's, or the x's with the x's. So 3.21, I need to add that to negative 7.52 to find what the vector v plus w is. So I'm now doing vector v plus vector w here. And that is equal to, it's going to be those two added. I have the 3.21 and negative 7.52. So I guess I should have added it all together on the same time, but it should be fine. 3.21 minus 7.52. Did you get negative 4.31?
What?
Did you get negative 4.31 for the x component?
Yeah.
Cool. I think you're ahead of me. 3.3 plus 2.74, 6.57. Yeah, nice. Okay, and that's the answer. That's all you're looking for today. I'll give you a preview of what's coming tomorrow. A preview of tomorrow is you're doing the same steps here, where you convert them to component form, add them in component form, but instead of giving this answer, you do another step and say, okay, now convert it backwards to the length in the argument, to theta and to modulus, all that stuff. All right, so that is example 1. Go ahead and do example 2 on your own, Daisy, and I will have it up on the board so you can check your work. Here's example 2. There's all my work, and there's the answer. Daisy confirms that that is the answer. So Rochelle, go ahead and write your summary now.